Good afternoon, and welcome to the Society of Wetland Scientists November 2020 webinar entitled Resurrecting Ghost Ponds and Other Approaches in Pond Restoration and Conservation, and presented by Emily Alderton. My name is Katie Christie, and I am pleased to moderate this webinar and engage you in an e-learning experience with SWS during a time when many of you are sequestered at home like me. This is our way to stay connected to the wetland community during the global pandemic, and we hope you all are well. For those of you who may not be as familiar with our SWS webinar series, all of our monthly webinars are complimentary to SWS members and are usually held on the third Thursday of the month. Once each quarter, we open up our webinars and offer them free to non-members and the public. As you can see on this listing of our upcoming webinars, we have both our regular SWS webinar series in English and also have quarterly webinars offered in Spanish. Our next free quarterly webinar will be held in December 2020, titled SWS History, 40 Years of Globalization, and will be presented by Dr. Kathy Ewell and her friends. We are proud to announce that we have 4 organizations that are sponsoring our SWS webinar series. The first 2 are the Water Resources, Hydrology, and Hydraulics Education Group, which is a nonprofit group that shares information on water resources, hydrologic, and hydraulic engineering to help educate and build a better tomorrow. Please visit, like, and follow the sponsor. And the Winton Group, which is a natural resource consulting firm that balances regulatory compliance with sound ecological management. You can find their information at the websites listed above. The next 2 SWS webinar series sponsors are In Situ Monitoring Equipment and Software works together to make it easier and more cost-effective to collect, access, and manage water levels, water quality, and water flow, and more. And the WildNote is a field data collection app for environmental professionals that streamlines the process of collecting, managing, and reporting environmental data so that you can work smarter, not harder. You can also find their information at the websites listed above. Please make sure to visit their pages or like and follow our SWS webinar sponsors' social media pages. Since January 2018, we have had most of our SWS webinars approved by the SWS Professional Certification Program as being applicable for continuing education credits. These credits can be applied to your Professional Wetland Scientist certification or renewal or other certifications. It seems even more important during the pandemic to gather as many CEUs as you can from online and virtual training sessions like these SWS webinars. We are pleased to announce that this webinar has been approved for continuing education credits. Participation certificates are available through an automated process. You will receive an email from our SWS Managing Director, Michelle Kosek, about 1 day after the webinar. Check your spam email if you don't see it. These certificates are free to SWS members and are available for non-members for a nominal cost of $20. Participation certificates are also available for those who watch webinar recordings, which can be found on our past webinar page or our YouTube channel, complete with multilingual captions. Before we get started, I'd like to go over a few housekeeping items. The general format for today's webinar will be a 45-minute presentation from our speaker, followed by approximately 15 minutes for questions. All attendees will be muted. Questions to be asked in the Q&A pane shown here, not in the chat panel. At any time during the presentation, you can type your questions into the Q&A button/pane. Participants may upvote questions in the Q&A that they want answered earlier. The chat pane should not be used for questions. Rather, if you have any technical difficulties or general comments, you may post them in the chat. Jordan will be checking that regularly. Handouts, PDFs is hosted on the SWS website. A survey should pop up at the end of the Zoom meeting. Please fill that out to give us feedback about today's webinar and the SWS webinar program. Additionally, please indicate if you are interested in giving a future SWS webinar in 2021. And also don't forget to tweet about today's webinar at #SWSwebinar. So it is my distinct pleasure to introduce our speaker today, Emily Alderton. Emily Alderton has a master's and PhD in aquatic science from the University College of London. Emily received her PhD from the Environmental Change Research Center at UCL in 2017 for her thesis on ghost ponds. Resurrecting lost ponds and species to assist aquatic biodiversity conservation. Emily's research focused on mapping historic pond loss across the country of Norfolk in the UK, understanding the impacts of pond loss and pond degradation on aquatic biodiversity, and investigating the potential role that resurrecting infilled ghost ponds could play in helping to restore biodiversity in fragmented pond landscapes. During her PhD, Emily was involved with the Norfolk Ponds Project, an award-winning multi-partner project working to conserve and restore Norfolk's ponds. Emily contributed to pond restorations, educational open farm events, and training days for farmers and landowners on how best to restore and manage ponds in farmland. Since 2018, Emily has been working in Massachusetts as an ecological scientist at BSC Group Incorporated, where she provides field services, including wetland delineations, habitat surveys, invasive species surveys, and federal, state, and local level permitting services. With that, I will hand control over to Emily. Welcome, Emily.
Hello, and thank you for the introduction. Let me know if you can't hear me at all. So today I'm going to present some of my PhD research on resurrecting ghost ponds. I'm also going to cover a little bit of other pond restoration techniques which have been being researched in the Pond Restoration Research Group at UCL. Thanks to all the people who have helped me with this work, my supervisors, my friends and family who helped me collect all the data, and for funding from the Natural Environmental Research Council and Norfolk Biodiversity Partnership. So, one second. So before we dive into the world of ghost ponds, I thought I should start with a little bit of background about ponds in general, and specifically ponds in the UK. So first of all, what do we mean by a pond? Unfortunately, there's no one great definition that distinguishes ponds from puddles or ponds from small lakes. I'm going to be working with this definition by the Freshwater Habitats Trust, which is one of the more common ones you see in the literature. That a pond can be a body of water anywhere between 1 meter squared and 2 hectares. It could be permanent or it can be temporary, and it could be man-made or natural. Now, obviously, that's a pretty broad definition. For the purposes of this talk, we are working with ponds at the sort of smaller end of that scale, as you can see in these photographs. The definition covers, as I said, both man-made and natural water bodies. Ponds in the UK, largely man-made. Many of them have origins in farmland for watering livestock, or for the extraction of clay and building materials, or mill ponds for running mills. And of course, then we also have some natural ponds, things like small glacial pingle ponds or oxbow lakes. So across the UK, we have a large number of ponds. They account for about 97% of our total number of standing water bodies, but only about 14% of total surface area, given their small size. So they're very frequent but small habitats. Many of our ponds are located within farmland. It's not particularly surprising. The UK is about 74% farmland, so many of these ponds are within that area. We still have a large number of ponds across the UK. A survey commissioned by the government in the late 1990s estimated that the number of lowland ponds in Britain was just short of about 230,000 ponds still remaining. However, if we compare that to estimates of how many ponds we used to have, for instance, work by Oliver Rackham in the 1980s, he estimated that across England and Wales in the late 1800s, we used to have closer to 800,000 ponds. So we've experienced quite significant loss of these small freshwater habitats. This is in line with what's happened across much of northwestern Europe, where countries have experienced between 40 to 90% loss of ponds. I think similar patterns have been observed across many other agricultural regions of the world, including North America. So why does this matter? Well, not only are ponds still a relatively abundant resource, but they can also have a very significant contribution to biodiversity. Their small size and the high heterogeneity between sites means that ponds can contribute disproportionately to both plant and invertebrate diversity. They consistently support more uncommon species in the UK than other types of water body, rivaled only really by rivers. As I said, many of the ponds in the UK are located within farmland. Sadly, these are often overlooked as a resource for biodiversity. It tends to be assumed that they're going to be fairly poor quality habitats of little value. These bottom three photos, you can see perhaps what we would consider fairly typical farmland ponds in the UK. One on the left that's been highly impacted by eutrophication and has just become an algal mess. One in the centre that's been neglected and has just become overgrown with thicket, probably not much water left in there. And one on the right, which is just gradually being encroached with the crops coming right up to the pond edge and tipping going into the pond. However, not all ponds are that sad. Some farmland ponds can be fantastic oases for all sorts of wildlife. The top two photos are both ponds located in the middle of agricultural fields. And as you can see, they're really quite diverse in terms of wetland plants and can have very nice clear water quality. So I've mentioned a few of the threats to ponds, obviously in those bottom photos, their overall degradation of this habitat. Probably the greatest threat facing them though is pond loss due to infilling, particularly for agricultural intensification. So I'm going to focus on the region of Norfolk, which is where I was conducting my PhD work. This is a county on the east coast of England. It's probably one of the pondiest regions of the UK still. There's currently about 22,000 ponds left. However, it has lost about 30% of the ponds it had in the 1950s. Here's a map of just the county of Norfolk now, and this shows pond densities in the region. So this is based on the Ordnance Survey mapping that we have. So you can see in the top figure from the 1950s, we've got really quite high densities of ponds, particularly across the centre of the county. You're looking at 20 to 40 odd ponds per kilometre square. Compared to 2014, when the most recent OS map I was working from at the time had been drawn, we see that that pond landscape has really been reduced in density and has become quite fragmented. So what does this look like kind of on a smaller scale or on the ground? If we look at this little region here, we can go to the village of Guestwick. No, sorry, the village of Wood Dawling, in fact. So this is in that central, previously very high density pond landscape. And on the left, we can see a modern OS map in which I've marked with a little red dot every pond that has been filled in since the 1950s. You can identify these by looking at the old Ordnance Survey maps. Top right-hand corner, we can see a map from the 1880s. I've just highlighted the ponds that were present at that time in red. If you compare that to a modern OS map or aerial imagery of the area underneath, you can see those red circles representing all of those ponds which have been lost. Only two left clinging onto the landscape still. So what happens to these ponds that are being filled in for land reclamation and crops? Well, these are what we have called our ghost ponds, because they leave this sort of ghostly presence on the landscape once they've been buried. You often see a wet depression out in the fields in the winter, perhaps, where the ground is still a bit saturated, or areas of poor crop coverage where things just aren't growing quite as well as in the rest of the field. So these ghostly presences you can spot all over the farmland in the UK. And I became really quite interested in what happens to the seed bank and the things that are buried within these lost aquatic habitats once we've filled them in and covered them with crops. So although I'm focusing on the UK, as I mentioned before, many agricultural regions across the world and Northwest Europe and also in North America have fairly similar habitats. Many wetlands have been filled in for agricultural land reclamation. These are a couple of photos from a report by Dahl in 2014, looking at prairie potholes that have been lost in the Midwest of North America. These are perhaps somewhat similar to our ghost ponds, again, ponds that have been infilled for crop production, but similarly are still leaving occasionally these little presences in the landscape where they once were. So I was really interested in seeing what happens to the seed bank and how can we maybe bring these ghost ponds back to life. So we started off with an experiment in the field where we found our ghost ponds and excavated them and recorded what happened out in the fields. Alongside that, we used a multi-tier experimental approach to investigate the role the seed bank had in bringing these ghost ponds back to the landscape. So to sort of describe this briefly, first of all, we have our ponds in the field, which were monitored as they came back to life. We also have a series of mesocosms, which are essentially mini plastic lined ponds that we set up around each parent ghost pond. And these mini ponds either contain sediment from the parent pond with the seed bank in that sediment, or they contain sterile potting soil so that anything dispersing in could grow there. And of those two treatments, half were left open for dispersal and half were covered with an ultrafine mesh that was small enough to exclude most seeds or spores from getting in there. So alongside those field experiments, we had experiments set up in a greenhouse where we had some microcosms, basically little plastic fish tanks, which we filled with filtered water and sediments from the ghost ponds that we were studying, as well as some controls. And finally, we took samples of these sediments from the former ghost ponds and took them down to the Millennium Seed Bank at Kew Gardens, where I performed some seed staining with tetrazolium chloride, which detects metabolic activity in seeds and oospores. So you can test whether the seeds you're finding in the sediment are still alive or not. So to just introduce you to the study sites we were looking at, we selected 3 ghost ponds which had been buried at different ages. Ghost Pond 50 on the top left, right in the middle of an agricultural field, called Ghost Pond 50 because it was buried approximately 50 years ago, based on the most recent map it appeared on, and the landowner could tell us a bit about the history of that one. We then have an older ghost pond, our oldest study site, which Ghost Pond 150, buried about 150 years ago, according to the most recent map it was shown on. This was a pond located on a hedgerow. And Ghost Pond 45, buried 45 years ago, again, another pond located in the middle of an agricultural field, which had been filled in. So because we were interested in how the seed bank, if it survived at all within these ghost ponds, might compare to the seed bank of a living pond, each of our ghost ponds was paired with a still existing pond in the same field. Now these were overgrown late successional ponds, which had become scrubbed up, full of trees and shrubs, but they did still retain water and did still function as ponds. So below each ghost pond is its restored pond partner, which we decided to restore and see how the seed bank of those ponds compared to that of the ghost ponds. So I'll take you on a little tour of one of these ghost ponds as an example. I'm going to use Ghost Pond 50. So this was the pond buried 50 years ago in the middle of this field. Quite difficult to tell, but it's in that sort of dip you can just about make out in the ground there. So the first thing we did was we located the pond based on the historic maps and based on the topography in the field. Once we were fairly confident we knew where the pond was roughly, we started digging. So we dug a test trench here, and you can see where we've gone through the topsoil layer, and we've reached that historic pond sediment layer, which is really quite distinctive. The black, anoxic, very fine, silty layer at the bottom. Let me have a look. So we can see, if we take a closer look at this pond sediment, apart from the colour, which gives it away in contrast to the topsoil above, you can also find all sorts of remains preserved of the past aquatic life. So things like pond snail shells in the top left. Bottom left, we have the preserved pondweed seed. And on the right, you can see the preserved leaves of broadleaved pondweed. So it becomes quite clear when you've hit this pond sediment layer. So once we'd identified where the pond was, we began excavating, or rather Dom did. Dom is the digger driver. He is in charge of digging these ponds out once we've found them. So the important part here is that we kept as much of that black sediment containing the historic seed bank in the ghost pond as possible. We have, at the first stage, we took out samples of the sediment for setting up our other experiments, but the rest we left in the field site so that it could help the pond recolonize. So we excavated the pond in September 2013, following the contours and sort of the rough shape depicted on the maps, and then otherwise just generally creating gently sloping and some shallow areas for plant establishment. So this is what it looked like the day it was dug. It took about a day and a half to dig this one out. We left the pond over the winter, and it fills naturally with rainwater. I should point out, most of these ponds we're dealing with here in North Norfolk are old marl pits, so they're naturally clay lined. They were originally dug by people extracting that clay, the marl, from underneath to spread on the fields and lime them. So these have I guess a naturally watertight basin underneath. So this is what the pond looked like in February when it had filled with water. We've marked out a 10-metre margin around the pond to act as a buffer. At the moment, you might notice what is growing in that margin doesn't look particularly like wetland plants. That is in fact the previous year's crop of broad beans, which sprang up from the seed bank to begin with. So give it a little bit of time. By May, so we're the following spring after excavation, the pond was looking a bit like this. It's not particularly happy looking, rather full of algae. We did, however, have one aquatic species, a stonewort, Cara vulgaris, and we've started to get some rushes developing along that pond edge. Again, the broad beans and a previous crop of borage doing well in what is supposed to be the natural pond margin at the moment. However, we persevered and waited. June time, the water's starting to clear. A few more species have begun appearing in the pond, although it's still quite algal dominated. By July, we see a real improvement in the clarity of the water. We've now got quite a few aquatic plant species, including the appearance of our first pondweed, which has sprung up in there, as well as thick beds of stoneworts. Stoneworts are quite uncommon in agricultural or farmland ponds. They tend to get pushed out when nutrient enrichment becomes too much of an issue. So we're pleased to see these coming up in these ponds in the middle of an agricultural field. By September, so this is 1 year after the pond was dug, we've got thick beds of aquatic vegetation. The pond margin is still looking a little bit sad. We've got some wetland associated plants coming in, but also a mixture of previous crops that have been grown in that field. But we do have, I think, 17 species of aquatic or wetland associated plant now appearing in that pond. So that was after 1 year, which was my monitoring period. But just as a little follow-up, after I'd finished monitoring these sites, I was sent a few other pictures of them. So this was the pond 2 years after it had been dug. You can see really nice thick beds of pondweed and water crowfoot now growing at the surface. And in 2017, so this is 4 years after the ghost pond had been excavated, we've got a really well-established pond now, lots of marginal and emergent plants around the edges, including cattails in the background, and really good clear water quality maintained in this pond. So apart from that 10-meter margin, this is still an agricultural field that's being actively used. It's not in a conservation area or in a larger protected area at all. So for comparison, I think I mentioned at the start that as well as our ghost ponds, we wanted to see how restored pond seed banks responded. So this is an existing pond in the same field as our ghost pond. And this is what that pond looked like to begin with, heavily overgrown with trees and shrubs. So this is back in September 2013. So this pond was restored over the same time span as the ghost pond. So the first stage in our pond restoration is usually to get in and remove some of the trees and thickets, opening the pond up to light, particularly from the south, so that we've got the light necessary to help those aquatic plants really establish. And also to allow wind mixing. If you have a completely enclosed pond by a ring of trees, there's not much mixing of the water going on. Once we got in and removed a large proportion of the trees and thicket, we then went in and removed those top layers of sediment, a lot of the mud and the slush that has built up in the pond over the years, mostly from decaying leaf material, to really take it back down to an earlier successional state, and excavating back down to that earlier successional seed bank. So this is what the pond looked like when we'd finished. The white colouring that you can see to the left of the photo, that is the underlying marl, the clay that lines the base of the pond. And the black is the pond sediment that contains many of those seeds and spores of aquatic plants. It's worth noting that when we do this, we're not stripping every single overgrown pond and resetting it to this first successional stage. We always work in a mosaic where there's a mixture of other ponds on this farm, many of which are left in the overgrown stage to provide, tree habitat for other wildlife. Only some have undergone this sort of extreme resetting process. Similar to the ghost pond, over the winter, our restored pond filled with water, but otherwise looking quite muddy and a bit barren at this point. However, fast forward to spring of the following year, and this is what the site was looking like. Extensive beds of stoneworts, the charophytes underneath the water, water crowfoot growing on the surface and spreading across the pond, and really providing fantastic habitat for plants and wildlife at this stage. So here's just a little summary of what we found in our study ponds. So the top row, we have our ghost ponds, in which we found between 18 to 25 wetland associated plants colonizing after the first year. This is quite similar. Oh, it's been cropped off. Apologies. Well, the bottom row shows our restored ponds, and they had between 22 and 26 water associated species colonizing over that first year. There was quite considerable overlap in the species that were found in both the ghosts and the restored ponds. So while my work focuses mostly on the seed bank, and we'll be returning to that shortly, I just wanted to mention that not only do these farmland ponds provide fantastic oases for wetland plants, but they also provide great wildlife habitat for many other species. So just to briefly mention some of the other stuff that's been going on in the pond restoration research group. Richard Walton was conducting his PhD there, investigating the benefits of these farmland ponds for pollinators, particularly pollinators that are agriculturally significant. So he's particularly interested in the pond margins and what develops in them. So here he is crouched in the margin of a different restored pond. This is not one that's been planted. This is one, if you leave them long enough, eventually that crop cover does disappear and get replaced with native vegetation. So his research has been looking at how these open water restored ponds can benefit the abundance and diversity of pollinators versus late successional overgrown ponds, which is largely what's left in the landscape of the ponds that still remain. So he's been looking at the importance that they have for improving abundance of pollinators. Similarly, not only are ponds important for insects, but they also provide great habitat for birds. In the UK, like much of Europe, our farmland birds have been in steep decline, threatened a lot by habitat loss, but also from lack of food, particularly due to pesticide use. So this is work from the lab looking at farmland bird richness and species richness and abundances. Similarly, open restored ponds were found to provide greater abundance and species richness of visiting birds compared to overgrown shrub thicket type ponds. And this is largely due to, it seems, an effect of these sites providing essentially feeding chimneys full of insects for birds. This is a study on emergence trapping of the restored ponds versus overgrown ponds. You can see the sheer number of emerging insects, particularly mayflies and chironomids, that come off these open water sites compared to the overgrown sites. So just to give you a little bit of background about how important these farmland ponds are for wider biodiversity, not just aquatic plants and the seed bank, which is what I've been studying. So to return back to that seed bank and our questions about our ghost and restored ponds. So over the first year of our experiment, we saw that they came back strongly with a diverse array of aquatic plants. The question now really is, where did those plants come from? Is it a real seed bank effect, or are they simply dispersing in from the wider landscape? So this is really where our experimental conditions come in to help us understand those processes. So first of all, we have our little mesocosms that were set up around each parent pond. As I mentioned at the start, but just to recap, these little miniature ponds either contained sediment collected from the parent pond, or they contained a sterile potting soil and sand mixture that was suitable for aquatic plants to root and to grow in if they arrive by dispersal. And of those two treatments, we then left half open to the environment to allow seeds to disperse in, and we covered half up with an ultrafine mesh that was small enough to exclude, even the smaller charophyte oospores were excluded by that mesh there. And what we found in our mesocosms, the bottom two images, we can see a couple of the covered, closed condition. So these are mesocosms that contain sediments collected from Ghost Pond 50, buried 50 years ago on the left, and the oldest Ghost Pond 150 on the right. And we did indeed find that these sediments generated successful germinations from a number of species, and including species, this overlapping species that were germinating in the ponds themselves. So here is a graph depicting the mean species richness occurring in our mesocosms. I guess the basic take-home messages for this were that we found ghost pond sediments from our 3 study sites contained the Propagals from at least 15 species of aquatic plant. Of those 15 species identified in the sediment, 12 rapidly recolonized the ponds themselves, and 8 also germinated in at least one of our experimental conditions. And we found that mesocosms containing sediments from our ghost ponds, and also separate mesocosms containing sediments in our restored ponds, both instances, those mesocosms containing the pond sediment showed significantly higher mean species richness and more germinations occurring than our open, sterile, dispersal only condition. There was also no significant difference in the species composition or the rate of germination occurrence between our ghost ponds and our restored late successional ponds. So we saw pretty similar patterns in species richness and the time over which these ponds developed in both restored and ghost ponds. So to support the work in our mesocosms, which were outdoors and obviously at risk of not being completely sterile or controlled, we had our little microcosms set up in the lab. So these were sealed aquaria that we filled with filtered rainwater. And then we included sediment from the parent ghost or restored ponds. And again, in these microcosms that were set up in a greenhouse, we got germinations, even from the oldest ghost pond buried for more than 150 years. Again, the same species occurring in the ponds were occurring in the mesocosms and in the microcosms. And finally, I took some of these sediment samples to the Millennium Seed Bank at Kew, sieved the seeds and oospores out and performed some tetrazolium chloride staining, which detects metabolic activity in the seeds. Unfortunately, it's been cropped slightly at the bottom, but on the far left, this is a juncus. I'm not sure what species from the seed, but it's a juncus seed, which actually started germinating while it was being prepped for staining. That was from the oldest ghost pond, 150 years ago, buried. Next to that, we have a charophyte oospore, in which we can see a red stain. So the tetrazolium chloride, when it comes into contact with tissue which is still alive, is still metabolizing, you get this red staining. So this is a viable or potentially viable oospore from a charophyte collected from Ghost Pond 50, buried 50 years ago. And then we have some Potamogeton natans, broadleaf pondweed embryos, collected from the 50-year-old ghost pond, again showing a successful red staining, suggesting that they contain viable tissue. So this is just a little summary table of those results. Really, the take-home message is just those final 4 columns. They represent our 4 different experimental conditions: the tetrazolium stain in the lab, the microcosms in the greenhouse, the mesocosms in the field, and then the ponds themselves. And we found that a large proportion of the species that were occurring in our study sites in the field, in the ponds, would germinate in at least one, if not all, of those experimental conditions. And we found successful germinations from all 3 study sites, from the oldest, buried over 150 years ago, to the more recently buried site, buried 45 years ago. So this has got some interesting implications, not just for restoring the ghost ponds themselves and bringing them back to the landscape and providing these biodiverse habitats, but the viability of this seed bank over such long periods of time can have important consequences for locally, regionally, or potentially even nationally rare or extinct species. So as a couple of examples, Uinanthia aquatica is considered an uncommon aquatic species in the UK. We restored this in 4 of our ponds during this study, 2 ghost ponds and 2 of the restored overgrown ponds. Another rare species, Nias marina, which is listed as a Schedule 8 species in the UK. This didn't come back any of my restored or ghost ponds, but this is a extremely rare species, which we managed to restore in a different pond restoration conducted in February 2015. This species was only otherwise known from the Norfolk Broads, which were a much larger wetland complex. It's not been recorded in a small farmland pond previously. And finally, another one as an example, Tolipella glomerata, which is one of the stonework type family. as a nationally scarce species, which we've seen restored to 2 ponds since restoring them and excavating that historic seed bank. So just to conclude sort of the key points of this work, really, we found that ghost ponds buried in agricultural fields could remain viable for an extremely long time, at least 150 years and quite potentially longer. That the resurrection of these ponds through simply re-excavating them and letting nature and the seed bank do its thing can bring back these habitats to the farmland landscape, where they provide fantastic oases for wildlife. And that this approach, it's cheap, it's easy, it's effective. It could be a really effective tool in conservation for reinstating these lost habitats and potentially even locally or regionally lost species. If you'd like to ask any questions, my email address is here. There is also a blog which gives more information on these study sites, or if you'd like to look at nice photos of ponds. It's a little bit out of date, but it's still relevant. If you're interested in hearing some underwater songs from farmland pond creatures, there was recently a radio show on BBC Radio 4, which is online and will be available for, I believe, another year. So if you're interested in the songs of underwater animals, that might be something you'd like to look into. Thank you for your time, and I think that's everything from me. There's a couple of slides that just have references on, so if you're interested in following up in any of the things I've stated or claimed to be true, you can check out those papers.
All right, great. Thank you, Emily. Okay, so let's get to some of the questions and answers. Again, I will be reading your questions that I have received through the Q&A button to the presenter. The most popular questions that have been upvoted to the top will be read first. If you forgot to ask a question or had to leave before the Q&A is over, you can email the presenter at the email address listed on this slide. So let's get started. I have a couple of questions that have already come through the Q&A. The first one, Emily, is how deep was the trench in Ghost Pond GP50?
Good point. Now let me think. It was a bit deeper than I am tall. I'm 5'4", so I'm going to say I think it was about a foot more than me, about 6.5 foot deep. Really, it depends on the pond and how deep it was originally, how far down that seed bank was buried. Generally, most of these farmland ponds are fairly shallow, so you're usually looking at sort of 6 to 10 foot depth before you hit that seed bank.
Okay, thank you. We have another question. What is the slope on the ponds? It says it looks relatively steep.
Yes, that's a good point. Potentially those photographs were a little bit misleading. So what we tend to do is try and create at least most of the edges of the pond at a nice shallow slope suitable for plant establishment. There's definitely a few slopes in there that are more sheer, the back edge of that pond. One factor in that is that we're trying to recreate not just the pond that's sort of most ecologically beneficial, but also trying to keep it true to its historic contours and shape. Many of these ponds were dug for marl. What they tended to do when they created these ponds is go in from one side, dig quite a steep, almost face on one edge of the pond, and then excavate the marl out from that side. So as a general rule in these sites, you have one steep edge where they dug the marl out, and then one gently sloping edge where they dragged it out with a horse and cart and then spread it on the field.
Good, thank you. The next one is more of a comment. Kelly says, no question, but this is a really interesting talk. Thank you for sharing your work.
Good, glad you enjoyed it.
The next question we have is, do you have any comparisons with ponds that have been impacted more recently?
So I suppose the question would be, when you say impacted, do you mean ponds that have been filled in more recently, or ponds that have been impacted in other ways, for instance, eutrophication or some other type of damage to them more recently? All of the ponds I've worked on were either true ghost ponds, which had been filled in completely, and that's been between 45 to 150 years ago, or our restored ponds again do tend to be older sites that have naturally become overgrown and reached a late stage. I haven't worked with any that have been impacted more recently than that.
Okay. Still got quite a few questions coming in. So the next one is, did you run into negative responses from farmers when you asked them if you could restore their ponds on their farms? Sorry.
That is a very good point. And yes, so in the UK, ponds in general have pretty much zero legislative protection. In farmland, doubly so. So really, this was working with landowners who were passionate about conservation and interested in restoring these sites for what they would see as the biodiversity reward in their land. In some instances, we've now been rolling this project out more broadly. We've restored about 200 ponds on different farms across Norfolk now. And as the interest in the work grows, people are opening up a bit more to the idea of it. A lot of landowners who at first would have just given us a hard no have now become a little bit more interested in seeing what benefits it might hold for them in field drainage, in improving the diversity of native pollinators, and so on. So that's, I guess, a changing landscape perhaps in how interested landowners are to partake in this, which would really benefit if there was more funding or agri-environmental incentive to do this, rather than just the landowners' love of wildlife.
Okay, good. Were any aquatic macroinvertebrates resurrected in the covered Mesocosms?
That's a great question, actually, and something I should have mentioned. Yes, they did seem to be. So in the Mesocosms and in the little sealed microcosms that were in the greenhouse. So they were pretty well controlled, the ones that were kept locked in the greenhouse. We did, in fact, get water fleas, Daphnia, and chironomid midges back from the sediments, even the 150-year-old pond sediment. So for sure, I think the water fleas were in the oldest pond sediments. The chironomid midges we did get back from the more recently buried sites, buried for 45 and 50 years. So yes, there is some potential there. And I'm sure all sorts of interesting evolutionary genetics you could do in looking at how those compare to modern populations.
Okay. Is the hydrology source for all the ponds surface water runoff, or is there a high water table influence? Do you think this was the historical water source as well?
So the water source in most of these ponds is really just rainwater collecting. So they are almost all clay lined in this part of the world. So they're essentially just sat on that impervious surface. So whenever you dig a hole, rainwater and yes, surface runoff will collect in it. Some of them were probably dug as they point out, as a water source, particularly for livestock. Even up until the 1950s, some of these ponds were still being dug to run agricultural machinery to provide water for cooling and things like that. So, yeah.
All right, we got another comment from Sarah. She says, phenomenal talk, Emily, really interesting and well presented.
Thank you.
The next question is, do you have any species list from these ponds from around the 1880s to see what non-seed bank species that are being restored, meaning that all species do not have seeds that are long-lived?
That would be very interesting to look at for sure. Unfortunately, I don't think anyone was recording that sort of data on these little ponds in the 1880s or early dates. It would be something you could do to some extent with like a paleolimnological approach. You could look at the seeds, the total number of seeds that were preserved, including all of the seeds that have died, and look at the diversity of all seeds compared to the diversity of the seeds that were still alive, would give you some idea. But you would still be missing, as you point out, species that don't produce many seeds or species whose seeds aren't preserved. It might be something you could look at in a better monitored site if you went somewhere like the Fens, where people and the Victorians had a great interest in monitoring the plants in it even back then. You might be able to get that sort of data, but for these sort of small anonymous farmland ponds, sadly not.
Okay. Next question's not really directed toward you, Emily, but it's, is there a PDF available of this talk? I don't see it on the SWS website like I usually do. So yes, a recording of this should be going up on the SWS website. We're recording live right now. And eventually it'll end up on our YouTube page as well. So you'll be able to find a recording of this talk. The next question, have you restored any natural ponds that were filled in to level fields for crops? I have done this and have also found that relic seed remains viable, including seed from glacial times that are not even existent today.
That sounds, yeah, fascinating. Sadly, I have not worked on any of that. I would love to. I know there was talk in exploring this concept in Norfolk with some of the older wetland habitats, including bogs and fens, for which you can get cores going back hundreds and if not thousands of years to see how seed viability might behave there. I'm not sure if that work is now being done or whether they managed to secure funding to look into that avenue. I certainly see no reason that it wouldn't be possible. There are reports from around the world of seeds living for hundreds to thousands of years potentially. So if the conditions are right and the seeds don't decay and manage to remain dormant, then I see no reason wouldn't be a very useful tool for natural habitats as well.
Okay. Have you looked at a groundwater connectivity between these ponds?
Not for these sites. I haven't investigated these for these ones. That may be something that other people have been doing in the lab. I'm not certain. My understanding is with most of these man-made marl pit ponds that were dug, is that they have relatively little groundwater connectivity. But I could well be proven wrong there. So that's something I'd have to follow up and ask other people about.
Okay. Thank you. We have Julian who's asked, do you have an idea of the impact resurrected ponds may have on the cycling of nutrients leached from the farmland? Does it help nutrient retention?
It's a good question, and would certainly be something that would be interesting to look into. I do not know much about that. I know a couple of months back, we had another interesting talk in this webinar series in which one of the presenters was talking about nutrient retention and cycling in cropped depressional wetlands in the US. And it'd certainly be something that I can imagine they would provide a sink of some sort for nutrient retention, particularly with the buffer strip around them as well. As far as I know, that's not something that anyone else in our research group has looked into yet, but it may be underway, I'm not sure.
Okay. Dan says, thank you for your time, great topic. And it looks like maybe one of our last questions coming up. Have you considered supplementing the Propagals with seeds of native species that are locally rare?
Yep, that is certainly a possibility. Again, in our sites, we've purely relied on what is historically present at the site or what disperses there naturally. Really just to, as I mentioned, the ponds provide quite heterogeneous and unique sites because they are relatively isolated from each other. If you start moving things around between them and introducing seeds from other locations, things can potentially get a bit messy. You may accidentally get something in there that you don't want there. However, with caution, there's no reason that you couldn't supplement a natural seed bank with seeds collected nearby that are native. Or similarly, if you have a site which has a very poor seed bank, perhaps you'd be able to harvest some of these historic seeds from a site that did have a good viable seed bank still. I guess I put a caveat on that of like with caution, if you don't really want to be moving things around too much in case you have some unwanted introductions.
Good. Looks like we generated a lot of conversation with this talk. Got a few more questions just came in. In GP 150, how deep underground was the original seedbed buried?
So it was buried about 6 to 7 foot deep. As I said, most of these ponds were fairly shallow to begin with. So when they were filled in, they're still quite close to the surface. Many of them were filled in at the same time that landowners were ripping out a lot of hedgerows. So what tended to happen is you'd rip out your inconvenient hedgerow so you can get your combine harvester in, throw the hedgerow in the pond, and just sort of skim over the top with a thinnish layer of topsoil, just enough to be able to plant on it. So in general, most of these seed banks we found in these agricultural ponds have been pretty close to the surface, yeah, sort of 6 to 10 feet from the surface.
Okay. Next question, are the resurrected ponds protected so that the farmers do not pump the water in the future?
That is a good question. Sadly not. These are ponds that have really got in on people's land who are interested in conservation themselves and who are really doing this just for their own love of wildlife and seeing these habitats restored. In terms of their long-term protection, that is sadly lacking. As I said, in the UK, ponds really don't have much legislative protection. We have the Water Framework Directive, which tends to protect larger water bodies, lakes and rivers. There's very little to protect small water bodies like ponds. And there's not really much in our agricultural policy to promote these as a conservation tool, which is something that the Pond Restoration Research Group at UCL and also the Norfolk Ponds Project, who are affiliated with this work, have really been pushing to try and get into legislation, you know, to promote the idea that these ponds are an important tool for biodiversity and they should be included in agricultural policies to get farmers some more incentive to have these things restored.
All right. Edward says, outstanding research. Thank you for all that you have done in this. And last question that just popped up says, asks, how much did it cost to restore one pond?
Relatively cheap. Now that will depend as well if you're working with a landowner who has their own digger for doing this, or if you're hiring someone. The biggest cost by far for us was hiring the digger driver to excavate these. And then otherwise we largely relied on volunteer work. You know, a lot of the local community likes to get involved with seeing these habitats restored. So we had plenty of volunteers who came to help grub them out and remove trees and so on. I think we looked at, the cost was between £200 to £300 per pond. For a larger site, maybe a bit more than that, getting on to £350, £400 to excavate. Yeah, and again, if you had the landowner has their own digger and is willing to do that excavation work as well themselves, then you're looking at less.
To what extent could you identify intact leaf material to species? Does some organic material persist fairly well in the former mucky surface?
Yeah, so we did tend to notice that some leaf remains were quite distinctive and probably could be identified, maybe not to species, unless it was something that was very distinctive, but could maybe to genus at least. However, plenty of plants, obviously, their leaf material doesn't preserve as well. It tends to be, I guess, the thicker, more sturdy plants, things like broadleaf pondweeds or lilies that have quite thick floating leaves that you were finding preserved in the surfaces. To be honest, the seeds are probably easier and more reliable to identify than the leaf fragments, but there is some scope for identifying leaf fragments as well.
Okay, great. That looks like our last question. So we'll get through the last few slides here for SWS. Thank you, Emily, again, for taking the time out of your busy schedule and during this strange time in history to share your expertise and insights with all those seeking to learn more about the creative ways in which to restore wetlands. Your research contribution to the evolving science of restoration truly matters. Oh, sorry. Our next SWS free webinar will be held on December 17th, 2020, and will be presented by Kathy Ewell and friends. who will be presenting their work on SWS history, 40 years of globalization. Our next Spanish SWS webinar will be held on December 9th, 2020, and will be presented by Carolina Roja Cazada, speaking about urban wetland, an opportunity to making sustainable cities. As a reminder, all the Spanish webinars are offered free of charge to members and non-members alike. And finally, be sure to subscribe or follow SWS social media channels like Facebook and LinkedIn to keep informed and support the society. We also have a YouTube channel where all of our webinars are posted 3 months after their original broadcast with multilingual subtitles, and newly added are our wetland interviews, one in English and one in Spanish, posted to our YouTube page. You can quickly link to those on the SWS website under the Resources tab and select Wetland Interviews. If you are Spanish speaking, be certain to subscribe to the Latin American and Caribbean region's Facebook page at the link listed here. Thanks again to Emily for her presentation and to our webinar sponsors, and thank you to our audience for participating today. Have a wonderful day and stay well.